Hey everyone. Okay, so I decided to first let just the images speak a little bit for themselves. That was just a short intro, and I hope it's visible on camera. I'm not sure how much you can see, but this is basically what I've been working on for the last year maybe, and it's a new dithering algorithm that we're just going to use for our e-paper monitor in the future. And this is like kind of a community driven I would say invention, or it's not really something new. It's basically taking 2 or 3 things that were already there and just putting it together, and this creates something new which hasn't been on the market before. So that's for sure. Nobody's doing it at the moment, and we're just going to be the first ones with Models Flow, and I'm very excited to explain you how it works. So basically what I'm doing there, what you've been seeing in the videos, it's error diffusion dithering. That means I'm just calculating an error. So if what we're basically doing for the really fast modes in our monitor, we're just driving the pixels either black or white, and that means if you do a grayscale, you will have like an error. So it's like wrong in one direction, and error diffusion just puts this error onto the next pixel, which makes it look quite natural. So what all the others out there in the market are doing right now, they're just doing Floyd-Steinberg dithering. This is just a variation of how to do it, and what I did is I used Atkinson dithering. So the main difference is basically that it just takes 75% of the error and discards the rest of the 25%. What this changes in E-Ink is that all the UI and the text just gets super crisp. On images, it's like a little bit on the dark side sometimes, and it loses some detail, but the trade-off in my eyes for the use case of an E-Ink monitor is just so huge, because mostly what we're going to use it for is just going to be browsing or coding and maybe reading. So we really want the text to be really, really sharp and just point out. So what Atkinson is really good is just that. So when they did the first Macs back then and did some like paint programs and stuff for it, they used this dithering algorithm too, because it just made the detail look really, really good. So I just kind of thought that would be something cool to try out. And I think because nobody has done it before, it's just that it like needs a lot of very fast running hardware, because we need 2 row buffers instead of 1. The reason is that the Atkinson dither, it just goes 2 rows down, so the arrow is not just spread like to the next row, but also to the second next row. And to implement that means we need a very fast DDR RAM that's like kind of taking all the buffers and going in there. And I think the others just don't have the hardware like we do. So Wenting did an amazing job in this project, and the whole enchanter board is just so many small details. Everything is so thought out that it's just, you can basically do whatever you want with it. It's like a lot of potential in there. So my idea was just to make the best dither algorithm that I can imagine, and I'm not like at the end of the road. I think I'm just at the beginning. So what I did there is this dithering basically. That changes a lot. But then I saw when I had it that it produces some weird artifacts, especially when using it with a computer. So the problem is when the error is getting calculated all the time in real time, what we see in a very fast Eink case like ours with 60 hertz or 40 hertz, that you get like a comet tail. So it looks like there's a comet flying when you move the mouse, because the arrow right down of the mouse cursor is going to change because the pixels are changing. So that's kind of awkward when you're using a monitor, and I think that the others have the same problem, but they didn't have a fix for it yet. So then I was like, okay, how can I fix this? I had so many ideas, tried out like, I don't know, 20, 30 different things, but now I finally found a solution that really works, and it's very simple. The reason how I do it and how it works is just, I'm just comparing every pixel to the pixel before. So whenever a mouse cursor moves, for example, over a grayscale area, everything didn't change in the grayscale area. It's still the same. Only where the mouse is really moving, I do really have a change there. And what I'm basically doing is I store every pixel's last pixel, or the last input it had, and then compare it to the new pixel. And this way we get a rock solid dither algorithm that has no problems with this comet tail. So when I move the mouse cursor, really only the pixels where the mouse is moving, they change, and all the rest stays the same. This means that the dither is a little bit stale on some parts of the screen, because when I move the mouse, I get new dither there, but maybe on the sides there's like a small edge. But actually in real use case, I tried it out a lot, and it's like invisible because it's still a random error thing. So like such small details, you cannot see it, and the fix is just amazing, because it means this can not only be used for browsing with very good UI and text and very, very fast transitions without any like repeating patterns that other dithering algorithms have sometimes, but it can also use for video. So I'm not at the end of the road. Like I said, I just started really exploring this, but if I watch a video and there's like not so much movement on the screen, maybe there's a person, like an interview like I'm doing now, and all the background is not changing. So this would mean that the background stays the same and there's nothing moving there. So it looks like really, really sharp. And yeah, so this is basically where we're at, and I'm just so thankful for Wenting and Alex for putting all this effort in. And if you have the means to support us on crowd supply, it would be so great if you can buy a product and just make this dream become reality, because I want to push Eink further to make us like 24-inch panels available. We have the means to drive them. We could do that, and if we create some momentum and buy those 13-inch portable ones, they're going to see that there's a market for it. And once they see that, we're just going to continue, I think, to have greater products. So small disclaimer, I'm just doing this as a community member. I'm not part of the main team. They're like, they do their job, and I cannot say what's getting shipped at the end. It's just I'm just a big fan of the product itself, and just trying to develop some better dithering algorithms for it. And I think there's much that can be done, and I hope you're going to join us on this trip.